Hello, we are FTC team Ctrl-Alt-Delete.
Ctrl-Alt-Delete is a FIRST Tech Challenge team. FIRST stands for Inspiration and Recognition of Science and Technology. It tries to promote STEM fundamentals through friendly competition. The FIRST began with FIRST Robotics Competition, which is for high school students. We are a part of FIRST Tech Challenge, which is another high school division. And it also has FIRST LEGO League and Junior FIRST LEGO League, which are for middle and elementary school students. This is our second year as an independent FIRST Tech Challenge team. Last year in our rookie season, we won the Connect Award, advanced to state, and placed 12. Some things we learned last year were don't be afraid to ask for what you need. The worst anyone can say is no. Mentors are extremely important to learn from and maintain relationships with, and working with each of our strengths, we can do more than we thought we could. We are very excited to take home the PTC Design Award this year and first place Inspire at our qualifiers. Now we will show you a video about FTC in our season.
Hi, I'm Woody Flowers, and I've been part of FIRST for a long time. I really love how FIRST helps us learn that working hard can be fun and profoundly satisfying. In FIRST, we do our best work while helping others and treating folks with respect and kindness. This ethos is something I like to call gracious professionalism. As you go through this first season, please remember that it is extremely important. In fact, it's expected that you practice gracious professionalism. Everyone. FIRST students, coaches, parents, volunteers too. It's not always easy, but it will make FIRST a sweet experience, and it can have a big positive impact in all areas of your life. So go be kind and creative.
Rockwell Collins welcomes all of our teams, mentors, coaches, volunteers, and parents to this year's season.
As a scientist, an engineer, and a business leader, I've always believed that learning is not a spectator sport. That's why I appreciate the FIRST motto, Sport for the Mind. We at Rockwell Collins are big FIRST Tech Challenge supporters. Each year, we're proud to donate $1 million to support FIRST programs. And our employees log thousands of hours as mentors and tournament volunteers.
As a longtime FTC referee, judge, and hardware inspector, it's been easy for me to see how FTC provides the science, technology, engineering, and math skills used here at Rockwell Collins. Whether students pursue a career in avionics, programming, robotics, or the fine arts, FTC will teach them skills they'll use the rest of their lives.
As an FTC coach, I can tell you, FTC is more than just robots. Rockwell Collins and I love how FTC teaches students to network and communicate with others, and live a lifestyle of gracious professionalism. My FTC team is a great example.
FTC teaches us to work together in high-pressure situations, help each other out, and solve big problems,
and at the same time improve the world around us.
All skills I use here as an engineer at Rockwell Collins.
Thanks for joining us for another exciting season of FIRST Tech Challenge, and may the tubes be ever in your favor.
FIRST programs inspire innovation, creativity, and help foster students' self-confidence, communication, and leadership. Welcome to FIRST Tech Challenge, and this year's game, Cascade Effect. A team consists of 2 driver operators, a coach, and a robot. The robot must be built from materials specified in a game manual and fit within an 18-inch sizing cube. But after the match begins, the robot can grow to any size. Each match is played with 4 randomly selected teams, 2 per alliance. Your alliance partner from one match may be your opponent in another. The game is played on a square playing field with a foam tile floor and low walls. The scoring elements are 160 plastic balls, 40 large baseball size, and 120 small golf ball size. 152 of these balls begin the match in the center field structure. Each robot can start the match with 1 large and 1 small ball loaded onto their robot. The center field structure rotates to one of 3 random positions and is set only after the teams have placed their robots on the field. IR beacons are located on each side of the center field structure to help guide robots in autonomous mode. Each alliance has 3 rolling goals, 30 centimeters, 60 centimeters, and 90 centimeters in height. The field also has alliance-specific ramps and parking zones. The goal of Cascade Effect is to score balls into the rolling goals and then to move these goals into scoring areas. Teams will play in 2 versus 2 alliances, with robots starting in front of their respective driver stations, one robot on the floor and the other on the ramp. During the 30-second autonomous period, teams use their pre-programmed robots to earn points by performing a variety of tasks, including driving from the platform to the playing field floor, releasing a cascade of balls from the center structure by knocking down the kickstand, scoring preloaded autonomous balls into any rolling goal, scoring preloaded autonomous balls into the center goal located on the center structure, and moving rolling goals into the parking zone. During the 2-minute driver-controlled period, teams will earn points by scoring balls in the rolling goals. Balls scored in the 30-centimeter high rolling goal are worth 1 point for every centimeter above the goal base that they reach. Balls scored in the 60-centimeter high rolling goal are worth 2 points per centimeter. And balls scored in the 90-centimeter high rolling goal are worth 3 points per centimeter. The end game is the last 30 seconds of the match. Teams can continue gameplay, but are also able to earn points by moving the robots and rolling goals into the parking zone and completely off the floor. However, if a goal tips over, all points will be lost. Teams can also attempt to score balls into the center goal during the end game. These are also measured by centimeter height, and since the base of these goals starts at 90 centimeters high, these valuable points can add up quickly. To avoid penalties, read the rules carefully. Among others, some basic rules include robots may not control more than 5 balls at any time. You may not interfere with your opponent's rolling goals. You must stay outside of your opposing alliance's parking zone and ramp area during the endgame. And if you tip over your opposing alliance's rolling goal at any time during the driver-controlled period, your opposing alliance will be awarded points equivalent to a full rolling goal. Please be sure to read the entire game manual and follow the Q&A game forum for the complete rules and penalties. Thanks for your gracious professionalism. Have fun, and good luck.
We were fortunate enough this season to have many mentors. Some of those include John Post and the engineers at TSI Solutions, Kevin Coates and the engineers at SMC Kentucky, Tom Papagallo, a senior project manager at Siemens, Frank Maxey, also a senior project manager at Siemens, Josh Stover, owner of Blue Media Supply, Brandon White Sr., director of software engineering at NetTracer, Brett Kearns, a flash systems specialist at IBM, and Keith Grant, owner of Corner House Inc. FIRST has given us opportunities to connect with these mentors, learn about real-world problems, and what these engineers look for when hiring. Our most helpful mentor has been Tom Papagallo. This is his 2nd year as our mentor. He has invested a lot of time and expertise into our team. One of his biggest contributions has been helping us with Google SketchUp and strategy and design.
Our team was very involved in the community throughout the season. Much of this involvement included numerous outreach events such as the Service Mount Technology Association Convention, Cisco STEM Day, the Georgia Manufacturing Expo, Family Science Night at Delmony Springs Elementary, 100 Scholars STEM Day, GRITS, a field trip at TSI Solutions where we gave a presentation on FIRST, and a Skype presentation to SMC in Kentucky. In addition, we gave a presentation on FIRST to Vantage Point Education Pre-Engineering class. We invited Team Genius to join us at Family Science Night at Mimosa Elementary School. In addition, we have been involved in other FIRST activities by opening our personal field to use by other teams and mentoring the F-Little Team Robo Elite, as well as mentoring rookie FTC team 9724 from Creekside High School. Finally, we put much time and consideration into strengthening our team by refining our roles, rules, and goals, and participating in team building activities such as dinners and laser tag.
There's a lot that goes into designing and building a robot. Although we agreed on strategy in the beginning, we had a debate on 2 design ideas. The original design used T-slot aluminum and pulleys to achieve speed and height. Though it seemed to be a better idea in theory, it was too expensive as we chose to focus financial resources on a full field this year. After assessing the resources from last season, the new design was created. It is very cost effective but slower and needed many prototypes to achieve the desired results. One of the prototypes was a 3D printed part. Though we thought of several ways to gather and score balls, we chose a linear slide and a lift arm to achieve height. The sweeper and the chassis are specifically designed to filter out small balls since they do not give as many points. On the back is a tail hook, a player-controlled latch used to drag a tube behind the robot to score. The motor drive uses 4 motors and is double geared to a 1-to-1 ratio. Double gearing helps prevent wear on the motors. The new design challenged us to achieve results with a tight budget, which is a real-world problem we'll face again. After each of the qualifiers, we focused on finding solutions to any mechanical and programming challenges we had. It is important as engineers to always be looking for ways to improve design and performance. We identify these areas of focus by doing in-depth debriefing after each competition.
When it came to programming this year, we learned a lot of new skills, including how to use Google SketchUp and Autodesk Inventor to create our 3D printed piece, more advanced Robot C programming, and how to use more tools such as the voltage meter. One challenge we had was getting the swing arm motor to spin forward and backward at a constant speed while holding down a button on the controller. We solved this by having a mentor come over and teach us what the programming was doing and how to solve it. He also taught us how to follow the logic of the program. For our driving strategy, we decided to have one person drive and operate the tail hook on the back of the robot. We had the other person score using the lift and the on-lift motor. After the first qualifier, we set a goal to work on an advanced autonomous program. We accomplished this goal for the second qualifier with the guidance from a new mentor.
2, 1, robots! And all robots are off! Look at that! Wow! 6278 is going straight for the small tube and is attempting, and we have scored 1 ball, 6278. Started 7369, 61, sorry, scored both. 10 seconds left. Cheer them on, they can do it. Go, go, go. Bye.
Thank you for watching. If you would like further information about FIRST programs, then please visit www.gafirst.org or www.usfirst.org.
To follow what our team's been doing, please visit us at team.Ctrl-Alt-Delete.blogspot.com.
Thanks for watching!